Welcome to another episode of CCSD Earth Science. Today we're going to be talking about the movement of groundwater. And two things that really come into play when we look at the movement of groundwater is what the soil and the rocks are like near the surface. Those are going to determine how the water can pass down from the surface down through the ground, but it also can affect how water can move and travel upward through the ground, like we'll talk about later on. One factor that we can look at is porosity. And porosity is the amount of pore spaces or holes that are in the ground and in the soil that allow the water to travel through. If there aren't a lot of pore spaces, then the water can't travel through as fast, and it's going to take longer for the water to drain down. So we'll take a look at some different things that can affect that. And so the big thing is how the rock or the soil or the sediment is sorted. The actual size of the particles doesn't affect the porosity. You can have really big particles and have really small particles, but that's not what really determines the amount of pore space. It's the shape of the particles and how they're packed together that determine if water can travel through easily or not. So if we take a look over here, these are three different examples with three different size particles. But believe it or not, they actually have the same amount of porosity because they're sorted by size. So over here we have a lot of big ones with a lot of big pore spaces. There's not as many pore spaces, but they're very big. We go to the next one. The size of the particles is a little bit smaller, but then the size of the number of pore spaces that you have is a little bit greater. And then you go over here, and the particle sizes are very small, and you have still a lot of tiny little pore spaces. So all of the little pore spaces here add up to the same amount as you have here and in here. So the size of the particles doesn't matter. It's how they're sorted. So this would be considered high porosity because there's a lot of little spaces or big spaces over here that the water can travel down through. Now if we take a look at this one right here, this is going to be a lower porosity because they're all mixed together with different sizes, or what we call poorly sorted. So the little pieces are filling in the big pore spaces that we had over here. So the water would have been able to travel down through here, but over here the small pieces are filling that in, so it's going to slow down that process. So the porosity is not as great here. So well sorted or particles that are the same size is going to create a higher porosity than something that's mixed together, or which will create a lower porosity. Now the porosity affects something that we call permeability, and the permeability is the ability for the water to come through the ground, to permeate down through. And so some things that affect permeability. If you have a soil with a high permeability, what that means is that the sediment, like we saw before, is well sorted. It's all the same size, so it's going to have more pore spaces. And the other thing with that too is that they have to be well connected. You could have really big pore spaces, but if there's no channel or pathway to connect each of them, the water can't go from each pore space to each pore space, and it just kind of stays in place. Now if you have something with a low permeability, a soil that doesn't allow the water to pass through very easily, usually it's because the sediment is mixed together, like we saw on the previous board, or the particles or the pore spaces are not well connected. And we see this a lot with clay particles because clay is very small and it's very flat. So you can see right here, they're just kind of layered and stacked in top of each other, and it doesn't allow for the water to come down through very easily. So if you live in an area where the soil contains a lot of clay, it's going to be more prone to flooding because it's not going to allow for the water to pass down through as easily. If you want drainage to occur quickly, you want larger size particles in your soil. So a sandy soil is going to allow that water to pass through much easier. And if you have, gravel or even something larger like that, that will also allow the water to pass down through much easier. When you have a situation like this where there's low permeability, that can really affect something called the runoff, which is the water coming down, the precipitation that we receive, and it running along the surface because it doesn't have a chance to soak in. If the ground is already completely saturated with water, it can't take anymore, so the water is going to start to pool up on the surface and start to run along the surface. You can also see runoff if the ground is at an angle where it's coming down faster than it can get absorbed, and that also will create runoff. So that can definitely be an issue when you start getting into urban areas where there's a lot of pavement. That's why it's really important when you're planning out a city to place drainage areas for the water to go to, because it can't pass through the cement or through the pavement. So runoff is because of low permeability in the soil. Now, we've been talking about water going down through the soil, but we can actually have certain cases where water will travel upwards, and this is something called capillarity. And that's, like I said, the ability for the soil to actually draw water upward through the ground. And this is going to happen the best when you have smaller pore spaces. And you can see right here, here's an example, okay? Bigger pore spaces, the water's not traveling up as high. And the narrower these tubes get, the higher the water can travel. The water is attracted to the other water molecules and also to the surface. So it just kind of clings to the side and it allows it to travel upward, which is acting against gravity, but because of that attraction, it actually will pull it upward. And you probably have seen this before if you've had like a little bit of water on the counter and you take a paper towel, you put it in, you can actually watch the water travel upward through the paper towel. That's capillary action. And capillary action is definitely important for us so that we can have water in our wells, but also for plants, because it allows the water to travel upward from the water table up closer to the surface where the roots of the plants can reach it and allow it to be used by the plant. So water can travel downward and upward, but all of that is dependent on what the structure of the soil is like. So the permeability, the porosity are going to affect the movement of water through the earth.